Angle sum formulas. You should be familiar with techniques used to derive the 6 angle sum formulas. You should be familiar with inverse trig functions and should be able to simplify fractions containing square roots, including the technique of rationalizing the denominator. In this lesson, you will use the formulas to find specific values. Here are the formulas for the sine, cosine, and tangent when adding or subtracting angles. Note that on the left-hand side you are asked to add or subtract the angles and then find the value of a trig function. On the right-hand side, you have 3 or 4 numbers found from trig functions that are then added, subtracted, multiplied, and divided to get the answer. Before we work some problems, let's ask whether or not we need these formulas at all. Could we compute sine of a plus b directly? In order to do so, you would need to know angle A and angle B so that you could add the angles. Maybe you are given information about the angles. In this case, the two angles add to 60 degrees, and we could find the sine of 60 degrees from the unit circle. But you may also be given information about the sine, cosine, or tangent of the two angles, and then you'd have to use the inverse trig functions to find the angles themselves before you could add. The formulas will give us a much more direct way to get the answer. Even if you know the two angles and can add them, you may not know the value of the sine unless the angle is one of the special angles on the unit circle. In this case, we'll have to rely on the angle sum formula. Let's finish this problem. We find the sine of 75 degrees by using the angle sum formula. Angle A is 45 degrees, and angle B is 30 degrees. We look up the values from the unit circle and simplify. Now let's do some examples. In this problem, we are asked to find the sine of a plus b. So we will use the sine of a plus b formula, which requires us to know 4 values: the sine and cosine of angle A and the sine and cosine of angle B. In this case, we are only given the sine of A and the cosine of B, and we'll need to find the other 2 values. We begin by labeling triangles and finding the remaining side by using the Pythagorean theorem. Note that angle A is given as a first quadrant angle, and therefore we use positive side lengths for all the sides. Angle B is a fourth quadrant angle, so the cosine of angle B will be a positive number, but the sine of angle B will be a negative number. Once we have labeled the triangles, we can read the appropriate values from the triangle, finding the sine and cosine of angle A and the sine and cosine of angle B. We are now ready to use the formula for the sine of angle A plus B, which calls for 4 numbers, which we have already found. We plug those 4 numbers into the formula and simplify. Here's a similar example. We may be given information about the triangles using inverse trig functions. In this problem, we have the inverse sine of 3/4, which is the angle whose sine is 3/4, and the inverse cosine of 2/3, which is the angle whose cosine is 2/3. We think of this problem similar to the previous example. We think of the angle A as the angle whose sine is 3/4, and the angle B as the angle whose cosine is 2/3, so that we are asked to find the sine of A minus B. We can label 2 triangles, find the missing side by the Pythagorean theorem. We then need to decide which quadrant each of these angles is in so that we can decide whether the values are positive or negative. Recall that the inverse sine function is always chosen to be on the right half of the unit circle, and since this is the angle whose sine is positive 3/4, that angle should be in the first quadrant. Similarly, the inverse cosine function is chosen to be on the top half of the unit circle in quadrants 1 or 2. And since this angle has a cosine value that is positive, that should also be in the first quadrant. Both of these angles are first quadrant angles. Once we have the triangles labeled, we can read the values of sine and cosine from the triangles. Use the appropriate formula, plug in the values, and simplify. The tangent angle sum formula is similar. First, we label triangles and use the Pythagorean theorem to find the missing sides. Next, we look up the values we will need to plug into the formula. Plug those values into the formula and simplify. Let's go through the simplification slowly. First, we find a common denominator, which in this case is 2 times the square root of 7, and rewrite all the fractions in terms of this denominator. Next, we multiply the overall numerator and denominator by 2 times the square root of 7. We rationalize the denominator by multiplying by the conjugate. In the numerator, we FOIL. The denominator is the difference of squares pattern. We combine the like terms in the numerator. Finally, we can move the negative sign from the denominator. To recap, in most cases, you'll be given the value of a single trig function for 2 different angles and be asked to find the value of a trig function with the angles added or subtracted. To do so, draw and label a triangle for both of the original angles. Find missing lengths by the Pythagorean theorem. Then use the appropriate formula. Plug in the values by reading them off the triangles and simplify.